Hello, and today's learning target is I can evaluate algebraic expressions with squares, square roots, and absolute values. Remember, in evaluating or simplifying expressions, we need to follow our order of operations. And the order of operations are PEMDAS, and PEMDAS stands for, the P stands for parentheses or grouping symbols. This could be under square roots, inside absolute values, above or below fraction bars. E stands for exponents. M stands for multiplication and division from left to right. So M and then D, they go hand in hand together, and the operation to complete first is just what occurs from left to right. Multiplication doesn't necessarily always come before division, only when it occurs from left to right. A and S, addition and subtraction, need to be completed from left to right. So again, addition doesn't necessarily always come before subtraction. Let's evaluate the following expressions. The first example says 35 minus 3 times 8. According to PEMDAS, we need to complete the operation of multiplying 3 times 8 first, and that gives us 24. So now we still have 35 minus 24. And 35 minus 24 is 11. Let's look at the next example. 18 divided by 9 plus 2 times 6. Well, according to PEMDAS, we need to complete 18 divided by 9 and then the 2 times 6 before we complete this addition operation. So 18 divided by 9 is 2, and 2 times 6 is 12. So now I will add together 2 plus 12 and get 14 for my answer here. Now let's look at 24 divided by 6 plus 2 to the third power times 4. So according to PEMDAS, I need to complete the exponents first. 2 to the third power is 2 times 2, which is 4, times 2, which is 8. So that's completed. Now I need to complete 24 divided by 6, which is 4. And then before I can add here, I need to complete the 8 times 4 over here. And 8 times 4 is 32, and now I can bring down the plus, so 4 plus 32 equals 36 for my final answer. All right, and let's continue on. 12 minus 6 in parentheses times 5 squared. So I need to complete the parentheses first, which would be 12 minus 6, which is 6. Times, and 5 squared I need to complete before I can multiply, and 5 squared is 25. So I have 6 times 25, and 6 times 25 equals 150. Let's take a look at a few more examples. So this first example, negative 13 plus the absolute value of negative 2 plus 5 minus 6. I need to first complete the absolute value here, and negative 2 plus 5 is 3, and the absolute value of 3 is 3. So now I have negative 13 plus 3 minus 6, and I'll complete the operations from left to right because addition and subtraction are interchangeable. And negative 13 plus 3 is negative 10, minus 6 is negative 16 here for my answer. All right, let's continue on. And I have the absolute value of negative 7 plus 3 times the absolute value of negative 11. So here, the absolute value of negative 7 is 7, and then the absolute value of negative 11 is 11. So I'll add in here the other operations, 7 plus 3 times 11. So now it's 3 times 11 that needs to be completed first, and 3 times 11 is 33. So I have 7 plus 33 to give me 40 as my final answer here. Okay, let's continue on, and again, remembering PEMDAS for our order of operations. The square root of 12 times 3 minus the square root of 8 plus 41. So underneath the square root here, I have 12 times 3, and that's 36. So this turns into the square root of 36, which is 6. Then over here, I have 8 plus 41. And 8 plus 41 is 49, so the square root of 49 is 7. So I have here 6 minus 7, and 6 minus 7 is negative 1. Let's look at this next example. 6 plus 3, or I should say the quantity of 6 plus 3 squared minus the square root of negative 4 plus 5. So let's first simplify the parentheses. And so 6 plus 3 is 9. 9 squared, let's write that a little bit better. 9 squared is 81. And then negative 4 plus 5 is 1. And the square root of 1 is 1. So this is 81 minus 1, and so my answer here is 80. Okay, so now let's look here at a couple of expressions to evaluate. So let A equal 7, B equal 3, C equal 4, and D equal 6. So what we'll do here is we are going to substitute in these numbers in for the variables, and with the order of operations, PEMDAS, simplify and evaluate these expressions. So let's take a look at this first example. The quantity of A plus B squared, which will translate into 7 plus 3 squared divided by 9 minus 4. And now we need to evaluate this. So parentheses comes first. So 7 plus 3 is 10. 10 squared is 100. Divided by 9 minus 4 is 5. So 100 divided by 5 is 20 for my final answer. Let's continue on over here at the second example. So if I substitute in my values for my variables, I have 2 minus 3, the quantity cubed, minus negative 12 divided by 6, all cubed. So 2 minus 3 is negative 1, cubed, negative 1 times negative 1 is 1, times another negative 1 is a negative 1. And then here I'm going to subtract. I have negative 12 divided by 6, and that would be negative 2 cubed. And negative 2 times negative 2 is 4, but 4 times another negative 2 is negative 8. So I have negative 1 minus negative 8. Two negatives together, chop, chop, make a plus. So negative 1 plus 8 is really 7 for a final answer. So some of these examples get quite elaborate and long. We've got to make sure you keep everything separate and make sure you keep the right signs on everything and to do the order of operations correctly. So let's look at this third example. I have 5 times 2 divided by the square root of c, which is really 4, plus 8. And if you notice, it's only the square root of c underneath the square root symbol, not with the 8. So let's simplify here. And in the numerator, 5 times 2 is 10. And then the square root of 4 is 2. 2 plus 8 is 10. So 10 divided by 10 is 1. And 1 would be my final answer. Okay, and now let's look at this example. I have c squared, which I gotta zoom out a little bit so I can see there. So c is 4. So I have 4 squared minus 6 all over 2 squared plus 1 squared. So 4 squared is 16 minus 6. All over 2 squared is 4 plus 1. So 16 minus 6 is 10. And 10 divided by 4 plus 1 is 5. 10 divided by 5 is a final answer of 2. So again, we completed expressions or evaluated expressions by using the order of operations, otherwise known as PEMDAS, and we also substituted in values for variables and simplified those expressions as well. Thanks for listening. Have a great day. Bye.